Today I want to tell you about the equations of motion which we use to solve the numerical problem. These equations of motion uses 5 different symbols. They are SUVAT. You can remember this as Subhat. In the same way, we can remember this as Utsav also. This is another name UTSAV. Remember these symbols as Utsav or Subhat. Now, what's the meaning of this symbol? I want to tell you about this. S is displacement, its unit is meter, and U is initial velocity, unit is meter per second. V is final velocity, unit is meter per second. A is acceleration, its unit is meter per second square, and T is time taken, its unit is second. All the units are taken in according to SI system. Okay, after this much understanding, we have to remember equations of motion also. First, v equal to u plus at. Second, s equal to u plus v by 2 into t. Third, v square equal to u square plus 2as. And fourth one, s equal to ut plus half at square. Using these equations, we can solve the numerical problem related to the uniformly accelerating body. Sometimes these equations and the symbol may be a little different this way. Just for example, instead of writing v equal to u plus at, v equal to u plus gt, g came in place of a. If a body is dropped from certain height, then instead of acceleration a, we'll use the symbol g. The same way, s equal to u plus v by 2 into t can be written as h equal to u plus v by 2 into t. Here s is replaced by h because both of them are length. That's why if a body is dropped, it covers certain height, and so we can write s also. In the same way, third one also, v square equal to u square plus 2gh. A is written as g and s is replaced by h because we are concerned with height. In the same way, h equal to ut plus half dt square. These are the equations a little different than the original equation, but we can use this equation also to solve the numerical problem. Now next, we have to remember few points before solving the numerical problem. In different numerical problem may be written like this: when a body starts to move from rest, if this type of language comes, it means initially body was not moving, it means it was at rest. That's why initial velocity is 0. Directly initial velocity is 0 is not written. Second case may be written this way also: certain numerical problem when a moving body comes to rest, or like this also, a car is moving with certain velocity but brake is applied and it is stopped. If a moving body is stopped, final velocity v becomes 0. You have to remember this. Directly final velocity is 0 may not be written in the numerical problem. Number 3, when a body is dropped from certain height. If a body is dropped from certain height, then what happens? Initial velocity is 0 because when it is in your hand, then it is at rest. It has no motion, that's why initial velocity is 0. But when it is released, then what happens? Every second its velocity goes on increasing due to the gravity of the earth, and it accelerates, and this acceleration is equal to acceleration due to gravity. That's why nothing is told, but we have given two information. If a body is dropped from certain height, u is 0, a is equal to g, and its average value is 9.8 meter per second square. In the same way, if a body is thrown vertically upward, let's say a body is thrown vertically upward after let's say a question we have: a body is thrown vertically upward with the velocity of 20 meter per second. How high it goes up? Now the question gives only one information, just initial velocity only, but two informations are hidden here. If a body is thrown vertically upward, its velocity goes on decreasing and at last final velocity becomes 0. This is very clear. And if a body is thrown vertically upward, it comes under the gravity of the earth. And that's why acceleration produces on the body, and this acceleration is equal to acceleration due to gravity. But direction is opposite. That's why acceleration is negative. It is minus 9.8 meter per second square. After this much understanding, we can take few examples which makes you clear about this condition. Look at this. Car is moving with the velocity of 90 km per hour. What is given here? Here, initial velocity is given, that is 90 km per hour. We can convert this into meter per second. Driver applied the brake. Brake is if applied, then final velocity becomes 0. V is 0. V is also given. And the car comes to rest in 5 seconds. 5 seconds is the time. U, B, and T, three informations are given. What is its acceleration? Acceleration is question. Now, which equation we have to use? We have to select an equation which contains all these given and the question. That is v equal to u plus at. Here we have u, v, t, a all. U, v, t, a. Using this equation, we can calculate acceleration. And answer is given, you can try it. The second one, a car is moving with the velocity of 54 km per hour. Initial velocity is given, u. Suddenly driver applies the brake on seeing a boy crossing the road. Brake is if applied, final velocity v is given, it is 0. And this distance is not real distance. Seeing a boy crossing the road from 25 meters ahead. The driver saw the boy at the distance of 25 meters. It doesn't mean that car covers 25-meter distance. That's why this distance is not used in solving the numerical problem. If its acceleration becomes minus 5 meters per second square, acceleration is given. Now calculate and write down whether the accident occurs or not. It seems to be nothing is asked in this question, but we have to find out whether accident occurs or not. How can we find out? We have to find first the distance. If this distance is 25 meter or more than 25 meter, then accident occurs. Otherwise, it doesn't occur. And question is designed in such a way that our answer is 22.5 meter. It means accident doesn't occur. Now, how to find out this 22.5 meter? Which equation we have to use? This equation. Why this equation? Because we have to solve an equation which contains u, v, a, and s. Here we have u, v, a, s. This is the particular equation which we have to use to solve particular numerical problem. Now, how to select this equation is now, I think, clear to you. Okay, this much for today.